10th Standard Algebra, Chapter 2, Quadratic Equations, Module 2. In this module, we learn solving quadratic equations by factorization method. Solutions of a quadratic equation by factorization method. Now, what do we have to do in this method? First, we have to compare the quadratic equation with the general form, that is ax square plus bx plus c equal to 0. We have to compare it with these equations and find out the values of a, b and c. So if we see a is a coefficient of x square, b is a coefficient of x and c is the last constant term. Then we have to multiply a and c. Then we have to split the resulting number into two such numbers such that we should get the middle term after adding or subtracting it. Let us see the sums. So we'll solve practice set 2.2, which is solving or finding the solution of the quadratic equation by factorization method. So first sum is x squared minus 15x plus 54 equal to 0. Now, if we compare this with the general form of the quadratic equation, a, that will be coefficient of x squared, that is 1. So in this, the coefficient of x squared is 1. So a will be 1. B, that is coefficient of x, is minus 15. And c, that is the last constant term, is 54. Now what we have to do first is we have to multiply a and c. So if you see a is 1 and c is 54, and 1 into 54 will give you 54 itself. Now 54 we have to split into two such numbers that after multiplying those two numbers I get 54, and after adding or subtracting I should get the middle term. So if you see in this case the middle term is minus 15x. So I have to get two such numbers that after adding or subtracting I should get minus 15. So if you see the two such numbers that I can take is minus 9 and minus 6. So if we check, minus 9 into minus 6 will be 54. That is this number back. And if I do minus 9 minus 6, so it will be minus 15. So, and minus 15 is a middle term. So the two such numbers that I can split it is minus 9x minus 6x. Now next what we have to do is we have to pair it. So I'll pair the first pair x squared minus 9x and the second pair 6x plus 54. Now if you see in the first pair I can take x common outside. So x is common out, inside the bracket you are left with x minus 9. Similarly in the second pair if you see I can take minus 6 outside and inside the bracket you'll have x minus 9. So you see here I have x minus 9 twice, so you can write it one time x minus 9, and here you have x minus 6. So x minus 6 in the another bracket, we'll write it and that equal to 0. So if you see you get here two factors, x minus 9 and x minus 6 equal to 0. Now by using the property, if the product of two numbers is 0, then at least one of them is 0. So you can say either x minus 9 equal to 0 or you can say x minus 6 equal to 0. So if you see in the first case, if you take minus 9 on the other side, you will get plus 9. And if you see on the second one, if you take minus 6 on the other side, you will get plus 6. So you have either x is equal to 9 or x is equal to 6. So the roots of the given quadratic equations are 9 and 6. Let us see the second sum, x squared plus x minus 20 equal to 0. Now in this sum, if we compare it with the general form of the quadratic equation, we get a is 1, b is also 1, and c is minus 20. Now if you multiply a into c, so you will have 1 into minus 20. And 1 into minus 20 is minus 20. Now minus 20 we want to split into two such numbers, that multiplying those numbers I get minus 20, and adding or subtracting I should get the middle term. So if you see in this case the middle term is plus 1. So I should get plus 1. So if you see, if I take 5 and minus 4. So if you see 5 into minus 4 will give you minus 20, and 5 minus 4 will give you plus 1, and plus 1 is the middle term, a coefficient of the middle term. So the two numbers that you can use to split up is 5 and minus 4. So the middle term I'll split it as 5x minus 4x. So if you see 5x minus 4x will give you 1x back here. So I split the middle term as 5x minus 4x. Now you just pair it. So I'll pair the first pair x squared plus 5x, and the second pair minus 4x minus 20 equal to 0. In the first pair, if you take x common out, so you will have x plus 5 inside the bracket, and in the second pair you take minus 4 common outside. So if you take minus 4 common out, inside the bracket you will be left with x plus 5 equal to 0. So I have here x plus 5 and x plus 5. So you write it once, x plus 5, and the second factor x minus 4. So you write x minus 4 equal to 0. So the two factors you have here is x plus 5 and x minus 4 equal to 0. Similarly, we'll use the property if the product of two numbers is 0, then at least one of them is 0. So you can either say x plus 5 equal to 0 or x minus 4 equal to 0. So in the first case, if you take plus 5 on the other side, you will have x as minus 5. And in the second case, if you take minus 4 on the other side, you will have x is equal to 4. So the roots of the given quadratic equation are minus 5 and 4. Let us see the third sum of exercise 2.2. So the question is 2y squared plus 27y plus 13 equal to 0. Now this, if I compare it with the general form, a, that is coefficient of y square, is 2, b, coefficient of y, that is 27, and c, that's the last constant term, is plus 13. Now you have to first multiply a into c. So if you see, a is 2 and c is 13. 2 into 13 will give you 26. Now 26 you have to split into two such numbers, that after multiplying those two numbers you should get 26, and after adding or subtracting you should get the middle term. So you see, if I take 26 and 1, so 26 into 1 will give you 26, and 26 plus 1 is 27, which is the middle term. So I can split 27 in two factors, that is 26y plus 1y. So 27y, I split it as 26y plus 1y. Now you pair it. So the first pair will be 2y squared plus 26y. Second pair will be y plus 13. In the first pair, you take 2y common out. So inside the bracket, you'll be left with y plus 13. In the second pair, since you see there is no particular number common, so you take y common, or 1 common out. So I'll take 1 common out. So inside the same thing, same terms will remain inside the bracket, that is y plus 13. So you see I have y plus 13 here, y plus 13 here. So y plus 13 will be one factor. So in the bracket I'll write y plus 13, and then you have your 2y plus 1. So 2y plus 1 will be another factor. So the two factors here you have is y plus 13 and 2y plus 1 equal to 0. Now again we'll use a property, if product of two numbers is 0, then at least one of them is 0. So you can either say y plus 13 equal to 0 or 2y plus 1 equal to 0. So in the first case, if you take plus 13 on the other side, you'll have minus 13. In the second case, if you take plus 1 on the other side, you'll have minus 1. And just little bit of rearranging, if you take 2 on the other side, so you will have minus 1 by 2. So the two solutions is minus 13 and minus 1 by 2. So the roots of the given quadratic equation are minus 13 and minus 1 by 2. This is the fourth sum of practice set 2.2. 5m square is equal to 2m plus 15. Now first we'll just have to rearrange this. We'll take plus 22m and plus 15 on the other side. So we will have 5m square minus 22m minus 15 equal to 0. Now if you compare it with the general form, a will be 5, that is the coefficient of m square. B, that is coefficient of m, will be minus 22. And C, that is coefficient last constant term, is minus 15. So you have to multiply A into C. So A is 5, C is minus 15. 5 into minus 15 will be minus 75. Now minus 75 I want to split into two such numbers, that after multiplying those two numbers you should get minus 75, and after adding or subtracting you should get the middle term. So the middle term here is minus 22. So if I take 25 and 3, minus 25, and if you take plus 3, so minus 25 into plus 3 will give you minus 75, and minus 25 plus 3 will give you minus 22. Sign of the greater number, that is why minus 22. So minus 22 you can split into two such numbers, that is minus 25m plus 3m, and rest terms as it is. So 5m square minus 25m plus 3m minus 5 equal to 0. Now you pair it. In the first pair, if you see 5m is common, so I take 5m common from both the terms. So inside the bracket you will be left with m minus 5. In the second pair, if you see 3 is common, so you will take 3 common outside, and inside the bracket you will be left with m minus 5 equal to 0. So you see m minus 5, and here also we have m minus 5. So m minus 5 will be one of the factor. And then the second factor will be 5m plus 3. So in the second bracket you write 5m plus 3 equal to 0. Now by using the property, if the product of two numbers is 0, then at least one of them is 0. So we can say m minus 5 equal to 0 or 5m plus 3 equal to 0. The first case, if you take minus 5 on the other side, you'll have plus 5. And in the second case, if you take plus 3 on the other side, you'll have minus 3. Now here in the second case, you have to take 5 also on the other side. So when you take 5 on the other side, it will get divided. So you will have minus 3 by 5. So the two solutions or the two roots of the given quadratic equation is 5 and minus 3 by m. So the roots of the given quadratic equations are 5 and minus 3 by m. The fifth sum of exercise 2.2 is 2x squared minus 2x plus 1 by 2 equal to 0. Now first what we'll do in this is we'll multiply the equation throughout by 2. So if you multiply the equation throughout by 2, that is each term you'll multiply by 2. So your equation so formed will be, if you multiply 2 by the first term, so 2 into 2 will be 4, 4x squared. Similarly in the second term, if you multiply 2, we'll have 4x. And similarly in the last term, if you multiply it with 2, so that 2 and the denominator will get cancelled. So you'll be left with 1 equal to 0. Now if we compare this with the general form, we'll have a as 4, b as minus 4, and c as 1. So if you multiply, now we have to split the middle term. So a, you find out a into c if you do. So a is 4, c is 1. So a into c will be 4 into 1, that is 4. Now 4 I want to split into two such numbers, that after multiplying the numbers I should get plus 4, and after adding or after subtracting you should get minus 4, because minus 4 is the middle term. So if you take minus 2 and minus 2, so minus 2 into minus 2 will be plus 4, and minus 2 will give you minus 4. So if you see, minus 4 is the middle term. Now you split the middle term minus 4x as minus 2x minus 2x. Now we just pair it. So you pair, the first pair will be 4x minus 2x. Second pair will be minus 2x plus 1. Now in the first pair, 2x will be common. So you take 2x common outside. So inside the bracket you'll be having 2x minus 1. In the second pair, if you see no such number is common, so you take minus 1 out. So if you take minus 1 out, inside the bracket you'll have 2x minus 1. So if you see here also we have 2x minus 1, and here also we have 2x minus 1. So 2x minus 1 will be one factor, and if you see here we have 2x minus 1. So the second factor will also be 2x minus 1 equal to 0. Now you take either 2x minus 1 equal to 0 or 2x minus 1 equal to 0. Now both of the factors are the same. So in both the cases, if you take minus 1 on the other side, you have plus 1. So you have 2x is equal to 1. Now if you take 2 on the other side, it will get divided. So you will have x equal to 1 by 2 in both the cases. So the roots of the given quadratic equations are 1 by 2 and 1 by 2. The sixth sum of practice set 2.2 is 6x minus 2 by x equal to 1. Now first what we do is we'll multiply the equation throughout by x. After multiplying the equation throughout by x, the quadratic equation so formed will be 6x squared minus 2 equal to x. Now if we just take plus x on the other side and just rearrange this equation, you will have 6x squared minus x minus 2 equal to 0. Now this, if I compare it with the general form, my a will be 6, b will be minus x and minus 1, and c will be minus 2. Now you just multiply a into c. So a is 6, c is minus 2, 6 into minus 2 will be minus 12. Now minus 12 you have to split into two such numbers that after adding or subtracting you should get the middle term. So the middle term is minus 1. And after multiplying those two numbers you should get minus 12. So if you take minus 4 and plus 3. So if you see minus 4 into 3 will give you minus 12. And minus 4 plus 3 will give you minus 1, and minus 1 is the middle term. So the two such numbers that I will use is minus 4 and plus 3. So I'll split the middle term as 6x squared minus 4x plus 3x minus 2 equal to 0. Now you pair it. So this will be the first pair and this will be the second pair. So in the first pair, 2x will be common. So you take it outside, and inside the bracket you will be left with 3x minus 2. In the second pair, if you see there is no such number or variable common, so you take plus 1 common out. You take plus 1 out, and then inside the bracket you'll have the same terms, that is 3x minus 2. So you see here we have 3x minus 2, here also we have 3x minus 2. So 3x minus 2 will be one factor, and then you have 2x plus 1 here. So 2x plus 1 will be the another factor equal to 0. So you either take 3x minus 1 equal to 0 or 2x plus 1 equal to 0. The first case, if you take minus 2 on the other side, it will become plus 2. And in the second case, if you take plus 1 on the other side, you'll have minus 1. So you have 3x equal to 2 or 2x equal to minus 1. And in the first case, if you take 3 on the other side, you'll have x equal to 2 by 3. And in the second case, if you take 2 on the other side, you'll have x equal to minus 1 by 2. So x is equal to 2 upon 3 or x equal to minus 1 by 2. So the roots of the given quadratic equation are 2 by 3 or minus 1 by 2. The eighth sum is 3x squared minus 2 root 6x plus 2 equal to 0. Now this, if you compare it with the general form, a will be 3, b will be minus 2 root 6 and c will be plus 2. Now if you multiply a into c, so a into c, 3 into 2 is 6. Now 6 you want to split into two numbers. So if you take minus root 6 and minus root 6, so minus root 6 into minus root 6 will be 6, and minus root 6 will give you minus 2 root 6. And if you see, minus 2 root 6 is the middle term. So I can take the two numbers as minus root 6 minus root 6. So I'll split the middle term as 3x squared minus root 6x minus root 6x plus 2 equal to 0. Now you pair it. So this will be my first pair and this will be my second pair. So in the first pair, you can take root 3 common outside. The first term 3, you can write it as root 3 into root 3, and you can take root 3 common outside. So inside the bracket, you will be left with root 3x minus root 2. Similarly, in the second pair, you can take root 2 common outside. So this 2, you can write it as root 2 into root 2. So inside the bracket, you will be left with root 3x minus root 2. So you see here we have root 3x minus root 2, and here also we have root 3x minus root 2. So root 3x minus root 2 will be one factor, and here you have root 3x minus root 2, so that will be another factor. So in this case, both the factors are the same, and that is root 3x minus root 2. So we have root 3x minus root 2 equal to 0, or root 3x minus root 2 equal to 0. So you take minus root 2 on the other side in both the cases, that will become plus root 2. So, and my root 3 on the other side, so it will get divided. So you have root 2 upon root 3. So the roots of the given quadratic equation is under root 2 upon under root 3. This is the 10th sum. So in this case, we have 25m squared equal to 9. So first what you do is you take plus 9 on the left hand side, so it will become minus 9. Now 25, you can write it as 5 square. So 5m the whole square will give me 25m square. Similarly, minus 9 or 9, you can write it as 3 square. Now here if you see, this is in the form of a square minus b square. And we know the formula for a square minus b square is a plus b, a minus b. So I'll expand this by using the formula. So I'll have 5m plus 3 into 5m minus 3. Now we can take 5m plus 3 equal to 0, or we can take 5m minus 3 equal to 0. The first case, if I take plus 3 on the other side, I'll get minus 3. In the second case, if you take minus 3 on the other side, you'll have plus 3. So we have 5m equal to minus 3 or 5m equal to 3. Now we take 5 on the other side, in both the cases it will get divided. So we have m equal to minus 3 upon 5, or we have m equal to 3 upon 5. So the roots of the given quadratic equation is minus 3 upon 5 and plus 3 upon 5. Here we have 7m squared equal to 21m. Here also we'll try to do the similar thing that we did in the previous sum. You take plus 21 on the other side. So you have 7m squared minus 21m equal to 0. Now if you take 7 common, in this case, if you take 7 and m common out, so inside you will be left with m minus 3 equal to 0. Okay, now if I take this 7 on the other side, it will get divided by 0. So you have m in the bracket m minus 3 equal to 0 divided by 7, which is 0 itself. So you have m into m minus 3 equal to 0. Now here what we can do is we can say either m equal to 0 or m minus 3 equal to 0. So if you take m equal to 0, you can keep it as it is. And in the second case, if you take minus 3 on the other side, you'll have plus 3. So m will be equal to plus 3. So the two values of m, or the roots of the given quadratic equation, are 0 and 3. We'll do one very easy sum. That's the 12th one. It is m squared minus 12 minus 11 equal to 0. So here what we do is 11, we'll write it as square root of 11. So if you take square root of 11, that will be 11 itself. So this 11, I'll replace it with square root of square root 11. Now here I can use the formula a square minus b square, and I can just expand it. So that will be a plus b, a minus b. So here you will have m plus root 11 into m minus root 11 equal to 0. So if you use this property, you have m plus root 11 equal to 0 or m minus root 11 equal to 0. In the first case, if you take plus root 11 on the other side, you'll have minus root 11. And in the second case, if you take minus root 11 on the other side, you'll have plus root 11. So m will be under root minus root 11 or plus root 11. So the roots of the given quadratic equation are minus under root 11 and plus under root 11. Thank you.